For this question, we're going to evaluate limit when x approaches negative infinity for this function. So try to substitute negative infinity. We can notice that we get infinity over infinity. So this is IDF form. In order to solve this IDF form involving surd, we're going to divide according to the surd here. So inside surd here, the maximum power is x squared. So we are going to divide surd x squared. So surd x squared in other form is modulus x. So modulus x you can define in piecewise function whether it will be positive when x greater than 0 or negative x when x less than 0. So when we dividing for surd part, we dividing surd x squared. So 4x squared over x squared together minus 3x squared because we have surd 4x squared minus 3 divide surd x squared. We can write it together. So meanwhile, for numerator part, where we don't have any surd function here, so we have to refer the simplest form when x approaches negative infinity. So it will mean the x is less than 0. So we are using negative x. So negative we can factorize out. So 3x over x plus 2 over x. So from here we simplify our function. Negative 3 plus 2 over x. And then over x squared can be simplified, leaving 4. Then we try to substitute our infinity again. So it will have negative 3 plus 2 over infinity, 0. 3 over infinity, 0. So lastly, simplify, we will have negative 3 over 2. So for this part A, what is important here is the first concept here. Divide by surd x squared. Then simplify and substitute, evaluate our x equals to infinity to get final answer. Then for question B, given a piecewise function here. So every time when we get a piecewise function, we suggested you to draw out the interval so that we know that at x equals to 5, this is value of 8. More than 5, this is ax plus 3. And then less than 5 is a quadratic function, x squared plus bx minus 2a. So find the value of a and b such that this function is continuous for all x. So in continuity, we have 3 conditions. First one, fa must be defined, means the point must be axis. So we can see here, this is coordinate 5. So before 5, after 5, and coordinate 5. So coordinate 5 must be axis. So coordinate f5 is equals to 8. So number 2, limit is axis. Number 3, limit approaches a is equal to the coordinate of that point. So in this case, when this function is continuous for all x, means we can find that limit approaches 5 from the left hand side, which is the function of x squared plus bx minus 2a. suppose can be equals to the coordinate of 5, which is 8. So this is our first information that we can get. And then at the same time, limit approaches 5 from the left hand side also need to equivalent to the point, so that limit exists and they are equal to the point. Then we're going to evaluate this. When limit x approaches 5 from the left hand side, we substitute inside x equals to 5. This is 25. And then coordinate of 5, f5 is equals to 8. And then for the right hand side, substitute 5. We have 5a plus 3. So we is equals to 8. From here we can get the value of a first. 5a equals to 5. So a equals to 1. Then we substitute a equals to 1 in order to find out the b. So this is how we find out the value ab by using continuous concept. So how to score here for the first mark is we have to know limit approaches right hand side, so be equivalent to the point, and then limit approaches left hand side also equivalent to the point. So here we'll have our concept and finding the answer, which is a is 1 and then b is negative 3. Then for question C, given y equals to this function, by finding the limit approaches appropriate point, then obtain the horizontal and vertical asymptote. So look at our fraction given here. We notice that denominator, which is x minus 4, x plus 2, cannot equals to 0. So the function is undefined when it is equals to 0. Means x equals to 4 and x equals to negative 2. So at this place, we were having vertical asymptote. So we're going to calculate when limit approaches 4 from the left hand side and limit approaches 4 from the right hand side to prove that we have a vertical asymptote at x equals to 4. Then another point will be x approaches negative 2 from the left hand side and limit approaches negative 2 from the right hand side. So substitute 4 into our function here. It will be 5 over 0. So when we have a value over 0, our answer is infinity. But this 0 is approximate from negative or positive. We have to test value. So 4 at the left hand side, we are going to test 3.99. So when we substitute 3.99 here, when we substitute 3.99 here, we can notice that it will be negatively approaches to from 0. So therefore, when x approaches 4 from the left hand side, we get negative infinity. So same procedure goes on for another one. So substitute 4, it will be 5 over 0. Then we know number divided by 0, undefined infinity. So whether it's positive or negative, we have to test. So we're going to test 4 from the right hand side means 4.0. Substitute here 4.0 minus 4, 4.0 plus 2. So it will be 0.00 something positively. So here we have positive infinity. Then repeat for value of negative 2. So when we have negative 2, when we substitute here, negative 2 plus 1, we have negative 1 over 0. So this is infinity. Test value to identify whether it is positive or negative infinity. So negative 2 from the left hand side, it will be negative 2.0. Substitute here, negative 2.0. Negative 2.01 plus 2, then time with negative 2.01 minus 4. So it will be approximate to 0 positively. So here we have positive infinity. So you can see positive 0 point something. So 0 positive, negative divided by positive, we have negative. Repeat again for the right hand side. Substitute negative 2. So we get negative 1 over 0. So this is infinity. Then we define this one is positive or negative. So test negative 2 from the right hand side is supposed 1.99. So we try to substitute here. Negative 1.99 minus 4. Then negative 1.99 plus 2. So you can see that is negative 0.0 something. So approaches 0 negatively. Then the whole fraction here conclude negative over negative. It is positive. So here we do the conclusion that we can find vertical asymptotes at x equals to negative 2 and x equals to 4. Then the next part, we're going to find horizontal asymptote. In order to find horizontal asymptote, we're going to evaluate limit x approaches negative infinity and limit x approaches positive infinity. So we try to substitute our infinity inside. We get infinity over infinity IDF. So we have to simplify our function here. So expand the denominator, we can notice that this is a quadratic, which is x squared minus 2x, then minus 8. So in the case of IDF infinity over infinity, we're going to divide the highest power of the x here, which is x squared. You can see all these are polynomial. So we're going to divide x squared. X over x squared, 1 over x squared, then x squared over x squared, 2x over x squared, negative x, 8 over x squared. Simplify 1 over x plus 1 over x squared, then 1 minus 2 over x minus 8 over x squared. Then we substitute our infinity here. 1 over infinity, it will be equal to 0 plus 0 over 1 minus 0 minus 0. So 0 over 1. Finally, we get 0. For x approaches positive infinity, also same. Since we already simplified this, so we can straight away evaluate. As you can see here, we already simplified, so we are having 1 over x, 1 over x squared. Then this is the simplest form that we already divide by x squared. So evaluate this, substitute 0 over 0, 1 over infinity, 1 over infinity, 0. So 1 minus, this is also 0, 0 over 1. So from here, we can do the conclusion saying that horizontal asymptote only have one, which is you have to stick up y equals to 0. So what is important here? Starting at the beginning, the concept of finding limit as approaches fall from the left hand side and right hand side, and then concept finding x approaches -2 from the left hand side and right hand side, and then both answers are correct, and then you have to state out this is our vertical asymptote with x, with the expression of x. Okay, then for the horizontal part, so we're going to evaluate to see you finding your x approaches -infinity, and we can see you simplify the IDF. So both of these you get 0. So horizontal asymptote here, y equals to 0. So horizontal asymptote must be doing limit x approaches -infinity and positive infinity.